Okay. Uh, okay. Good afternoon, everyone. I hope you are able to see the live stream. Okay. I welcome you all to this webinar. So today I will be presenting a webinar on Android application security. I will be talking briefly about the Android basics and how to test for the common vulnerabilities. So let's get started. Okay, so a brief introduction about me. So I'm working as a security consultant in Security Layer 7 from the past 2 years. I also do bug bounty in my free time. Uh, I have found several bugs in Verizon Media, Hotstar, Sony, Dell, Netgear, and about half a dozen other companies. Then I completed my OCP certification last year, and recently I completed my CRT certificate. I'm also a member of SRT, that is a MACRED team. Then coming to Secure Layer 7, I think Secure Layer 7 needs no introduction. But in brief, I can say that Secure Layer 7 provide end-to-end security for a variety of domains. We do pen testing for web applications, mobile applications, then the clients, network security. We provide red teaming services and a lot more. Okay. Let's come to the key points of this webinar. So I will briefly touch upon the basics of Android application. I will also cover the attack surface that we have in Android app. This is applicable also for iOS application. This is applicable for mobile applications. Then I will talk about uh, the pen testing setup that is needed to test Android applications. And then in the last, I will discuss about the common Android application bugs, how we can test for them, and how the developers can defend against those. Okay, so let's start with the basics. Okay, so the Android applications are basically written in Java, Kotlin or C++. These are the Java-based application, and the APK file that we see in the Android app, it's nothing but a zip file which has some compiled resources. I will also discuss this in brief in the next slides. So let me discuss about the Android compilation process. As I said, Android application are Java based. So basically the Java code is first written and then it is passed through a JavaC compiler, which then gets converted to the Java bytecode, which are called as classes. This process is similar to all the Java based application, but the next steps that we have are very specific to Android. Suppose this ProGuide tool is used to optimize the source code. So suppose this class file is like 60 MB in size, and if you pass it through ProGuard, then it will rename the classes, the methods, and the variables that we have in the code. It will also remove the redundant code that is not used in the entire application. So the 60 MB file can be converted into a 10 MB file, which is a very optimized file. Okay, this process is optional. You can do it or you can choose to not do it. Depends on you, but it will also provide obfuscation to the source code. So it will also act as a defense against the reverse engineering attacks against the APK files. Then the next step is this bytecode is passed through a DEX compiler. DEX is nothing but Dalvik executable. So this DEX code is a executable file that is compiled specifically for the Android application. Okay, then the next step is DEX file is passed through Android packager, and then it gets converted into machine code or native code that we call as APK file. So it's a very basic compilation process. These steps are similar for all Java applications, but these are very specific to Android applications. Okay, let's move to the next slide. So we have the typical APK file structure here. So once we decompile an APK file, we will get an Android manifest file. Then there will be some folder and some text files and ARSC files. I will just show this in a brief. I have one application at mind. Okay. So this is the application. This is a Diva application. This is basically the intentional vulnerable application which was made for like CTFs. I will just briefly extract the contents of this file using 7-zip. You can directly extract it. Okay, so now we have this folder. As I said in the previous slide, now we have these files. There is Android manifest file, then classes.dx, then res meta info. This is the common structure for all the Android application. The Android manifest file contains the meta information about the app. Let me go back to the slide. Okay. Okay. Okay, so the Android manifest file will contain the meta information about the app. It will contain the app name, the package name, the different activities and services that are used within the application will be defined in this file. Then this meta-nf folder is essentially a manifest of metadata information. It will include some developer certificates. Then this is classes.dx file. We talked about it earlier in the compilation process. So it will contain the code in the DEX file format. Then we have lib file. So lib directory, it will contain the native libraries that are used by the APK. Then there is a res folder. Res folder will contain the resource files such as pictures, images, then XML files. Assets directory will contain the JavaScript files. Suppose if the application is a cross-platform application built using some JavaScript framework, then those JavaScript files will be present in this assets folder after the decompilation. And this resources.arc will contain the compiled resources in a binary format. This can be images or strings. This is a typical structure of any Android application. Okay, this is a sample Android manifest file. As I said earlier, it will contain the package name. So in this case, this is the package name of the application and this is the version. These are the SDK version that is supported by this APK. So the device needs to be on the minimum SDK version of 12. Then it will be able to run the application. If you see, it has asked for internet permission. So basically, this to communicate with the internet, to communicate with the backend, the application will need this permission. This is very common in all the Android application. Then this is a provider which is not exported. This is a provider name, and this receiver. This is a typical structure of how the Android manifest file looks like. So it will contain the application structure and the different components are defined in this file. Okay, let's talk about the basic Android components. So we have activities, then broadcast receiver, content providers and services. These four are the basic app components. The activities, so when you launch any Android application and whatever you see on the UI, that is an activity. So it detects the UI and handle the user interaction. So if we are touching the APK or the application, we are interacting with the activity. Then coming to services, they handle the background processing associated with the application. We also have like broadcast receiver. So the broadcast receiver will handle the communication between Android OS and the application. For an example, we can define a receiver to show the battery status when it is very low. So when the battery of the Android will comes down to 20% or in the lower category, then Android OS will send a receiver, will send a broadcast. That broadcast will be received by the application and it will display the message according to the functionality. So it will display that the status is at 20%. Then we have content providers. So these Android applications will store some data at the client end so that the functioning can be smooth. So this data on the client end will be saved in some database files. These content providers are used to interact with that database. So these content providers will handle the data and the data management issues. This is the usage of these content providers. Okay, now let's talk about the attack surface for the Android applications. This attack surface is going to be very similar to iOS or any mobile application. When we are dealing with the Android or mobile application, the attack surface is very different than dealing with the web applications. On the web application end, we only have this network part, right? Because the application we are loading it in browser and it's interacting with the network. right? So there's only communication is happening at the browser level and at the backend level, right? But in Android application, it's very different. And in Android application, we have like 4 attack vectors. You can say the network that is common in the web category as well. Then we have like data storage. As a Android application is a binary file, so it will store some data at the client end. So in case that the device got stolen or some attacker gets access to the device, then he will be able to extract this data from the that is stored on the local storage. Then we have user input. As I said briefly, there are content providers which interact with the local database, right? So this user input vector can be used to gain SQL injection attack on the client end, right? Then we have this IPC. IPC means inter-process communication. So basically, it will so IPC is used for communication between different Android components. So suppose if we want to invoke any activity from another application, then we will send an intent, and that will be that activity will get invoked. So this is like another very interesting attack vector when it comes to Android application. Now let's talk briefly on each of those. As I said, in the network, this will include testing for the OAS, different categories in OAS that we have for web pen testing. There will be some exception like CSRF, because CSRF is not really possible in case of Android application. Then there is like also for reflected accesses. So in reflected access, the attack vector is like we sent a URL to the victim, and when the victim visits it, he will get the JavaScript will get executed on his browser, right? But this is not possible in case of Android application. Then as I said earlier, data storage attack. So the application will be storing some kind of sensitive data on the Android device in the form of internal storage or external storage. This can be database files, screenshots, or some different any random files. So if it contains like sensitive data, then it will get into this category. The sensitive data can be also stored in the logs file as well as in the memory. So this is a common attack vectors when it comes to data storage. Okay. Then as I said, input attack, user input attacks. So the Android application will have a database file, and it will use the content provider to interact with that file. So it will be running SQL queries for this interaction. So SQL injection will be possible through those content providers using this user input. Then there is the static disclosure or crashing the app using user input. The buffer flow. So in case of Android application, as they are built in Java and Kotlin, so there will be no buffer overflow in those cases because Java and Kotlin have protection against buffer overflow. But if the application is using any C libraries, then that C library might be vulnerable to buffer overflow. But this needs to be investigated, and we will have to spend a lot of time for this. Then IPC attacks. As I said, IPC attacks is a very unique thing for Android application. So we will discuss how we can do the IPC attacks and what are the intents. Okay, let's talk about the intent. Okay. So an intent is to perform an action on the screen. So it is basically used for invoking any activity, sending any broadcast, or starting any services, or sending messages between different activities. It is used for inter-process communication with different application. There are like 2 types of intents, like implicit intent and explicit intent. Let's go for some examples. Okay, so when we are interacting with application, we'll suddenly get some number, right? So if we click on that number, our phone dialer or the app that we use for calling will directly open. And the same case is there if there is any URL. If you click on that URL, it will directly go to the browser and it will open the web page on the default browser. So these are the examples of implicit intent. Then explicit intent, this needs to be defined. So if you want to start any activity, or if you want to start any services, or if you want to send any broadcast to any broadcast receiver, so this will come under the explicit intent. Okay, that's all about intent. uh, so let's consider the Android pen testing setup. So the main requirement for the setup is having an emulator or a physical device. For emulator, you can go for Genymotion. Genymotion is the most popular emulator that everyone is using for pen testing. But I prefer having a physical device because it will optimize. It will make your work very efficient. It will not hang, and you can directly interact with the physical device using your fingers. So it will make the process very fast. And there are these common tools like ADB, APK tool, JADX, and Expose framework, FIDA. These are used. These help us in the reverse engineering process or in debugging the application on the runtime. So these are some of the essential tools that are required for Android pen testing. Okay, so let's move on to the common Android application bugs. I'll briefly talk about the different categories of vulnerabilities that we have discovered in our pen testing. And I will also show how we can replicate those on our end using just few tools. Okay, so the first one is Android manifest file misconfiguration. Okay, let me just show you some. I will show you this as a live example. So we had this dewad beta APK. I will just load this in a JADX application. Okay, I have this JADX. Let me load this application. Okay, this is the one. So once we load any APK file in the JADX, it will just show us all the content of the application, including the Android manifest file, then the different Java code that is there. So if you go to resources, then we can see this Android manifest file, right? Now coming to the common misconfiguration. So when we are analyzing Android manifest file, there are certain flags that the developer set on their end. Now in this case, if you can see, there is a flag that is called as allow backup. It is set as true. So this is one of the misconfiguration. So if this flag is set to true, then anyone who got access to the device will be able to back up the application, including the user data that is being stored by that particular application on the local storage. So this comes under the misconfiguration. Then there is also a debuggable flag which is set to true. Right, so this means that anyone will be able to debug the application on the runtime. This is another misconfiguration. So when we are analyzing the manifest file, we need to check for the permission that the application is requesting. In this case, it is writing to external storage and it is also reading from external storage. This permission is okay. So it might need to get some data from the external storage, but writing means we have to check what kind of data is getting written on the external storage. Now this can be credentials or any kind of sensitive data. So this is a good entry point when we are testing the application, and this we can analyze from the Android manifest file. We will get the idea that okay, this application is writing some data to the external storage, and we need to investigate it further. Okay, then we also have like exported components. Okay, let me go to some activity. Exported. Okay. So here you can see that this content provider is exported. So this is also another good entry point. We can guess this from the manifest file. Okay, so that was all about the Android manifest file misconfiguration. Let's come back to the slide. Okay, so that was about the Android manifest file misconfiguration and how we can do it using the JADX tool. Then coming to missing anti-reversing defenses. So when we are pen testing any Android application, so we set some criteria which is defined by the OS mobile testing guide. The next slide is this. Okay, so the OS testing guide decides states that this protection needs to be present in the application, whatever we are testing, this needs to be present. So only after that we can state that this is very well protected against reversing attacks. Root detection is very common in Android application. Most of the applications that deals in finance, like banking application, they will have this protection. Then anti-debugging detection, reverse engineering tools detection, emulator detection. These are very essential. I will I'll shortly I will just show my Android device and tell you how the root detection works. Okay, so give me 1 second. I will just mirror the screen of my testing device. Okay. Okay, I'm facing some issue with the screen mirroring. Give me 1 second. Okay. Okay, I was going to show how this root detection works, but there is some issue with the screen mirroring. Give me a few. Will try it again, or then else I will move on. Got it. Okay, so this is my testing device, and I will just show you how the root detection works. This is a rooted device. I will some I guess some banking application. Let's go for SBI. Okay, SBI, and I will show how the root detection works. SBI, you know, that is the application name. Okay, we'll go with this one. So it's a compliance requirement for all the banking applications to have very strong protection against root detection. As this device is rooted, now once I install this application, this won't run on the device. And I guess close some pop-up that the device is rooted. Let's okay, okay. Yeah. So this is how the root detection works. Implement some protection on the client end, and uh, and then they do some checks, like check for the presence of SU binary, or the presence of root privileges from the client side, and then they decide that this device is rooted. So this is very common. I cannot show the bypass live, but this is very common, and there are lots of tools that we can use to bypass this. There is a one tool called there is a one framework called Expose Manager. It has some tools like root cloak that can use to bypass root detection. Then there is a Magix module called as site that we can use to bypass the root detection. And the last tool is the FRIDA or objection. So if nothing is working, then we can go with the FRIDA and write some custom scripts that will help us in bypassing the root detection. Okay, so was very is very common, and then there must be filter detection as well. So if you are running the application in Genymotion, then it should detect that this is running in the emulator, and it should not go to the next activities. Okay, let's go to the next interesting vulnerability. It is like sensitive hard coded data. Okay, I will also show this live. We already uh, loaded the Diva application, right? So in JADEX, so we will check for like hard coded strings. You can just do a text search the entire for giving. It's right now decompiling. Okay, in the meanwhile, I think we can check this manually. Okay, okay. So as this is an intentionally vulnerable application, we will find lots of stuff here. Code activity. If you can see API keys there 123 secret API key 123. Then there is a Diva username and there is password as well. So basically, by just loading the application in JADX, we can search for this. Where is the search feature? Okay, we can search for it like password, and we just need to analyze the whole result for any hard-coded data that we can use for further exploitation. So now hard-coded data can be like credentials, it can be API keys, then AWS secrets, S3 buckets. S3 buckets are like good starting point. S3 buckets are mostly misconfigured. So if you have an S3 bucket, then we should do further enumeration on those buckets to find any misconfiguration. So this can be done using JADX. The another way to do it is using the APK tool. We have to, sorry, I will just delete this folder. Okay. So another way to decompile the application is using APK tool. So let's see if I have it installed. Okay, APK tool. The syntax is d-apk. Okay, so this APK tool will decompile the whole application into small files, and then we can grep for strings that we find interesting, like API keys, password, credential, or S2 buckets, whatever we can think of. Let it complete, then we'll do the search. Okay, so this is done. The decompilation is done. Now let's say so we have this new folder now here. We will go to the folder, and if you can see, all the code is here now. Now we can just directly search for any string that we want. I will just put some flag with grep to make it easier to find out where the file is, where the string is located. I will search for like password. Let's see if it's there. Okay, we have yeah, lots of data with the password. Okay, so now after we got this result, now we just need to check all this file one by one, or check if it is really a password or just a false positive. Right. So the point was we can do this using the JADX. We can load the APK file in JADX and see the source code, or we can just decompile the application using APK tool and then do the search manually. Right. So if you can see here, we got the API key, then the username diva, and then password, and the location for this is like in Somali code. This file. Okay, that's good. Let's move to the next slide. Okay, so in earlier slides, I talked about the application storing sensitive data on the client end, right? So now we will check how to test for those data, how to exploit it. Okay, I'll share the screen of the Android device. Okay, right. So this is the Diva application. This is the same application where we check for uh, um, which source code we have already analyzed using JADX. I'll just open the application. It has some ensure data storage. It's a setup like application, so vulnerable. We'll just go to this part one. Okay, as this, I will just type some string here. Okay, so it is sending. Okay, now the next thing is connecting to the device. For that, I have like the device using ADB. Okay, let me just do this. Okay, it's great. So my go-to way to connect to device is using ADB wireless. So there is this application called as ADB wireless. Uh, yeah, this is the one. So if you just type this command ADB connect 1.2 and the IP address, we will get connected to this application directly. Okay, so we are connected and we can type the ADB devices command and it will list out the devices, the connected devices, right? Okay, the next is I'll go for ADB shell, and this ADB shell is like from normal user, so I will just change it to root user because we need this to access the directory where the application is storing data, where the Diva application is storing the data. Okay, so I will do SU. We got the root access. Now I will go to the directory called cd data. Okay, so basically this directory has folders for all the applications that are installed in the devices. So this is a folder made by this injured Android application. Now we just want to look for the application folder. So this is the folder created by the Diva application. So if this application is storing any sensitive data, it will be in this folder. This is one of the locations where we have to check for sensitive data. Let me cd into the folder. Okay, cd Jakar Diva. I will just clear the screen. ls. Okay, so these are the different directories. So when we are testing for sensitive data storage, we have to check in this directory. In the database, we might find some database files that would contain credential in the plain text, or in the shared database, we might find some external files that will have some kind of sensitive data. So this is one of the location where we can check for insecure data storage vulnerability, and this is how to check in the. This is the container folder by this application. This is the one entry point when we are checking for this kind of vulnerabilities. The another is checking on the SD card or the external storage. So sometimes the application will store some kind of data or some kind of files on the external storage. So we need to investigate there as well. Then the next part is logs. I'll just go to slides. Uh, okay, insecure data storage. Okay, so these are the different files where we can check for sensitive data, and there is also log files are generated by all Android application. The process to check those logs is very similar. I will just show this in a brief. Okay, let me go ADB. The command is ADB logcat. So it will just list out all the logs from all the Android applications. So the output will be very messy. You will have to create the output. Like if we are checking for password, then we will have to just grep for password, and if we are lucky, then we will get the credentials from the log files. So the difference between checking the local storage and log files is we do not require any additional root privileges to check logs. So it can be done on the normal non-rooted device as well. So this is very interesting, and this is very common in Android applications to store sensitive data on the local storage. Now the next part is attacking. Okay, where is it? Okay, the last category is attacking Android components. I will go back to the application, this Diva application. So this is basically attacking the components that are exported. So it can be activities or the services or the broadcast receiver. We need to investigate those, and then we can check if those are exploitable. So there is this ninth part is access control issues, right? So we will go there and we will view this API credential activity. So basically there is this activity present in the application which contains some sensitive data. So our goal is to directly invoke this activity. So first we will check the information about this activity. It's vendor API credentials. Okay, this is the source code that we have for this application. Okay, so we are checking for access control issue, right? Okay, okay, so this is the I think this is activity, and right, we'll check if we can invoke this activity directly using ADB. We can use the ADB to invoke this activity. So the syntax is like ADB shell AM for active manager and -n. Then we need to give the application package name. Let me get the package name from the Android manifest file. Okay, the package name is this, right? So we'll go back here, and the activity name. Okay, what is the activity name? So we check for this API creates activity. Okay, so this is the. I will just move this application to background and let's see if we can invoke this activity. Okay, it's not working. Okay, let's go to Android manifest file again. We might be missing something. It is also this another activity API creates to activity. Let's see if we can invoke this directly. API creates to. Okay. It's not. Okay, so let's skip that. There is also this application called as activity launcher. So basically, it will list out all the activities that are present inside all the application. So it is just loading. It will just check what are the activities are there in all the Android application. Okay, give it a second. Okay, so we have the every data is loaded. So let's go to the Diva application. Okay, this is here. If you can see, all these activities are locked, so they are not exported. We can't access those. But the main activity is exported, so we can access it. Then there is this activity as well, API activity, and this vendor API credential activity. We can directly call those. I think there was some syntax error when I was going through it using ADB. Okay, let's keep it. No worries. We'll directly click on this vendor API credential. Let's see if we can work right. So that is basically attacking the exported components. So we can directly call this activity from using any application, because it is exported. It has intent filters. So all the activities which has intent filters are exported, and we can exploit those. We can attack those. Okay. I think yeah, that's all. That's all from mine. So if anyone has any question, you can drop it in the chat. I have access to the YouTube. I will answer those. Okay. Okay. I think we can close the session. Thank you everyone for joining. Thank you for listening.